Hi, students. Today I'm going to talk about price projection. So what's the price going to be? Suppose the price of Apple 133, what's going to be the price a month from now? Or if you're interested next week, then you do the analysis, what's going to be the price next week. Now, you can tell me, Yusuf, you did Bollinger Band. It's about projection. Yes, if you go there again, let's share the screen. Yes, if we go to the Bollinger Band, Finance, if you use, for example, the S&P index for just, that's the most one in my face. Okay, so then here is a Bollinger Band. This is a moving average. So we say, yes, now the price of S&P is overbought. It's very high and it's below the moving average, so it's going down. Yeah, but we didn't say two things. We didn't know how much it's going to go down, what's going to be the price, exactly what's going to be the price, or some information, what's going to be the price. And then I didn't tell how long it's going to take the process to go down. Could be 1 month, 1 week, 6 months. So we need a more sophisticated model to project the price for a company or for any asset, index, whatever it's that interests you. So this is the assignment that I need to do for today, which is price projection. Here, indication, that's a price indication where we stand. But I need a projection, and these are two different things. Now, there are two main models that explain price projection. One, assume that there is a random walk. That means the price for today has nothing to do with the price for tomorrow. And we call this a random walk. The other one is price consistent or with serial correlation. That means the price today influences the price of tomorrow. So there are two competing models. One assume that we are on a random walk. One assume that we're not in a random walk. And in fact, both are right. It depends what asset you analyze. It depends on the time horizon. So most likely, if you analyze daily, if you're a daily trader, most likely the random walk assumption is right, which is the price go in a random walk, noisy traders pushing the price up and down. So it doesn't matter what's the price today, it's a random walk. If you do the analysis monthly or maybe annually, it will be different. It will be more as the price of today influences the price of tomorrow. So there are two competing models. I'm going to analyze two of these models and then using a company. I'm going to use Apple today and see what we can learn from Apple, current price, future price, some analysis about Apple, so we can have an idea how to project the price. Your homework will be to replicate the work I'm going to do here. It's a long video and it's a tough videos here. This is a PhD level quality here, but I simplify things to be simple for you. But if you do a PhD level, so I simplify things in Excel, but in the PhD level, you do more complicated things than that. But you have to know that. You have to know price projection. So we're going to do it. And bear with me, and I hope you will enjoy the journey. I really want to give the top notch of the science. I really want you to do the best in our field. So I'm sure that you're capable and you're smart and you're hardworking. And as I said, this is a fantastic class if you take it seriously. So let's do it. Let's see the price projection, not indicator. Indicator, we did that in the Bollinger band, but now we need to go projection. What's the price today? What's going to be next month? So let's do it. We're going to share the screen as always. We're going to go to Yahoo Finance. So we said we're going to talk about Apple. So you do AAPL. You open Apple. And then you say, okay, that's the price of us. So that's Apple 133. I need to know to analyze what's the future price for Apple. So I need to go to historical data for Apple. And then for our analysis, we would like to have 16 data observation. You can do 24 data observation, but 16 to 24, this is the sample size. Now, it's important here now. You want to do analysis for the next day price of Apple or next week or next month. If you're a daily trader, then you're going to collect data about Apple in the past 16 days or 12 days or 24. If you're a weekly trader, you have to collect data about weekly data for Apple in the past 16 or 24, 10, whatever you want to do. Monthly. So I'm going to do for our analysis a month. If you do daily, you can do it. You can do weekly or monthly, and that's it. You cannot go annually. That becomes to be uh, very long term. I'm gonna do monthly actually. So suppose I'm gonna buy Apple for 1 month. Is Apple gonna go up, gonna go down, or flat? So I want more information about that. So I do monthly, and then I have 1 year. 12 observations should be fine. Do apply. Click apply. Perfect. Download. Perfect. Open it. Perfect. Now how to calculate return? Simple. RETURN equal to the price of Apple today minus the price of Apple last month divided by the price of Apple last month. Done deal. We got the price of Apple, the return for Apple. Uh, Here we go. The last observation is bad. We're gonna delete it. Delete all of that. Delete. Fantastic. So now from this data about Apple return in the past 12 months, so what does that mean? 0.21, that means the return for Apple between August and July. That's a big return, by the way. And then they went down, and then they went down. That's a big return, huge, huge return for Apple. So probably they have earnings, and that summer earning, yeah. So from this, you need to get the distribution moment. This is a distribution. The return for Apple over months is a distribution. So we need to do is distribution moments. So there are many moments for the distribution. The key one is the mean and the standard deviation or the variance. Okay. Well, the mean for the return is this, amigo. Enter. Okay. Okay, so that's a mean for Apple. The standard deviation is this. You go, okay, here and click here and look how much beautiful. Here we go. That's the standard deviation. So these are the two moments for the distribution. The third moment will be skewness and other things. There are 3, 4 moments for the distribution, maybe more. But the key are this, the mean and standard deviation. Let me make them here in light gray. So you understand these are the key moments. So we're going to use everything about Apple, all the information about Apple, cash flow, revenue, contracts, iPhone, supply chain problem, China, tariffs, consumer sentiment. All this are already here. All of this information is here. Look how much beautiful finance. All of this information you need about Apple is already here. These two moments summarize all of this great information. So now I have these two moments and I'm going to solve the projection. Again, we're talking about price projection, not indication. Indication, we did that in the Bollinger Band. Now projection. What's the price for Apple next month? Is it Apple going to go 2% next month? What's the chance for Apple to go 5% next month? So we'll take these two, and then we're going to do some simulation of projection. So what we need to do is copy this Excel, and then in your folder, you will find an Excel file named price projections. So what I want you to do, go use that. And then I'm going to do there just pass. And that's it. So I put that here because I want to have all the Excel in one place. So I got the data. I got the two moments here. Life is beautiful. Everything is perfect. Now, what's the projection for the price? Price projection for Apple. I'm thirsty. As I said, there are two models. One is a random walk. One is not a random walk, serially correlated. Serially correlated means the price today influence the price of tomorrow. We didn't know yet if Apple is a random walk, the price for Apple going random walk or serially correlated. So we're gonna do both models, and then we're gonna decide which model we're gonna use. You didn't need to do both models. You can do some indication and know whether it's a random walk or not. But but for the class, you need to know both models to show you the results, and then you decide which model you're gonna use for your projection for the class purpose. But you, in the real world, you didn't need to do both models. Once you got this the screening, you will know which model to go with. But we're gonna do both models now. Okay, so we said there are random walk model, and we call that Monte Carlo simulation. You go to the handout. If you go to the handout, there is something called Monte Carlo simulation. This is a French professor did it in physics, actually, this model, but then we use it in technical analysis and finance. Finance, we are very great field because we always go to the math, the physics, and other science, and we see something cool, we bring it, and we always develop their products and their methods and frameworks, and we do a spectacular job in finance and economics also, I should say. All right, so what's Monte Carlo? Here's definition, background, key assumption. So this guy, Monte Carlo is a nice place in Paris, in France, and there is a radio called Monte Carlo. So if you go there, you're gonna like this place. Um, and then key assumption and the model specification here. It's a very mathematical model here. So you need to see how there are formulas and other things like that. But I don't want to go to the math. We're gonna go straight to the Excel and see what we're gonna do there. All right, so now we got the mean and the standard deviation. I'm gonna copy these, and that's enough for me. I'll copy those. I wanted to go to Monte Carlo simulation and right click and put values here. Okay, put values. So now we got the mean and standard deviation for Apple. And now I'm gonna create a thousand projection. I create sorry simulation. I created for you 1,000 simulation, and you go down to 1,000 if you wanna. Here we go. So it's 1,000 simulation here. Okay, good. Now, when we analyze a company, so the price, this will come here. Here, so there's a formula here that I show you in the handout. There's a formula here, so it's already here. This is a formula. We did that already here. So it's already in Excel. So you didn't need to do it. And then here you equal H7. See, equals H7. And how to do the simulation? You do this to calculate the simulation. You go data, what if, data table, you click here, you do this, okay, and boom, the simulation already up. So you have a step by step how to do it, which is you choose these two, right click, what if, data table, click here, you choose any empty cell, you do okay, and you got that, okay? That's a simulation, 1,000 simulation. So this simulation means they took the mean and the standard deviation and they created 1,000 different scenario for Apple. Now, when we analyze a company, we have to compare the company with the benchmark. The benchmark in finance is the S&P in a return. We expect from this month, we see June or July, till next year, we expect the S&P to do 10% perform from now till the June next year. So basically monthly, we're talking about 10% divided by 12 is 0.8%. So now the simulation starts. The first simulation is what's the chance, for example, that Apple beat the market? So basically, what's the chance that Apple, in average, their month will perform above 0.8%? So that's a 0.8% means 0.008. So I want to have it. What's the chance that Apple will beat the market? That means Apple, on average, in the month, they're going to have something above 0.008, enter. So the chance is 54.8%. So that is a chance here, very good chance that Apple will beat the market. What's the chance, for example, that Apple perform below than 5%? So you do 0.05 divided by 12 because of 12 months. So for annual year to be below 5%, you need the return in a monthly level average to be below 0.04. So that will be here. Then you have to say, what's the chance that Apple will go below below 0.004? There we go. The chance is 43%. There's a chance that Apple will do 5% or less next year. So what's the chance Apple will perform, for example, above 1% a month, which is a 12% a year, 1% a month? And then what you do is simple. Here, above 1%, enter 56% chance that is going to happen. So you can do a lot of simulation here. What's the chance for this? What's the chance that Apple perform between 15% and 10%? Between 1% a month and 1.5% a month. Well, let's do that. Between, let's say, 2% a month or 1% a month. Well, here we did the 1%. Now I'm going to calculate the 2%. What's the chance for Apple to be at 2%? So the difference between this, so 1% or above is 52. 2% and above is 48. So the difference between this and this says that there is a 3.8% that Apple will be between 1 or 2% a month and above 1%. So this is kind of simulation you can do it with Monte Carlo. And that's under the assumption that we have a random walk. If you have a question, keep asking me, email me, watch the videos multiple times. You can go and they have a Zoom with me if you need. So that's one assumption. But what if Apple is not a random walk and follow a process? Well, we're going to go back here. We're going to get this data from Apple and use a different model to understand if it's a random walk or not. So the other model, which is the opposite type of model, Monte Carlo, called Markov chain leapfrog model. Why I call it leapfrog? Because the frog jump, and I use it in my research. The frog jump, and then they wait a little bit, and then jump again, and they wait a little bit. They're not jumping back and forth, because it's a very careful species is the frog, and we can see that in price of oil prices. They follow the leapfrog model, which means they go high for a little bit and then they move a little bit for a few months. They don't move very fast. If they move very fast, then that will be a Monte Carlo type of model. So we call this Markov chain model. Here's the definition, key assumption, and what's the model? The model assumes that there are two states. Of course, if you do a PhD level, we'll do more than two states. But for the Excel and capabilities we have, we're going to assume two states, low and high. And then suppose you want the stock, let's say Twitter or Amazon or Apple, it doesn't matter here, have two return states. One is down. The first one is down, where the return are down. And state two up with our up return. And there is a probability. If you are a low to go, if you're state one going to state one is alpha, that means the complement will be state one to state two, 1 minus alpha. If you are in state two, like a state of up or high, the chance to go to low is 1 minus beta, but then you're up and you go into up again, the probability is beta. So these are the matrix. Depends what's the current state, you are up or low in the current state. And then we give you a matrix of what's the chance to go from low to low, low to high, high to low, high to high. And then the model, you have to calculate four parameters: R down, R up, alpha, and beta. Okay. So how to calculate these four parameters? You have to follow two steps. And here's step one, and there's step two. Okay. So you need to read this stuff. But now you say, Joseph, you go quickly now, 1 minute. Don't worry. Why? Because I'm going to Excel, back to this, back to Excel, back to the Word document, back and forth. It will become to be very clear to you. So the idea here, the theoretical model is here. The empirical is there in Excel. So we're going to go empirical, theoretical, empirical, theoretical. So we got that done. And then we're going to do final inference about Apple. And then you're going to replicate this work. Okay, let's go to Excel. So we said all the information about Apple is here. So we're going to copy the return here. Control C. You're going to go to the leapfrog model and put them here. Right click, pass values. All right. So this is Apple return. But in the handout, we said that you need to have, the first step is to calculate the return equal a constant A plus rho RT minus 1 plus epsilon T. So I need to calculate, I need the RT, which is I just have it. I need RT minus 1, and then these are regression parameters that I will estimate. So what is RT? Is the return for the company at time T. RT minus 1, the return for the company at time T. This is a constant. And rho is a serial correlation parameter, reflects whether we have a random walk or not. If rho equals 0 means a random walk, and otherwise it's not a random walk. The epsilon T reflect the error term that reflect the unobservable. So first we need to go to Excel, estimate this model, get the alpha rho and the epsilon T here, and then go to second step. Okay, we're gonna go to Excel. We're gonna go to Excel. So we have the RT minus 1 is simple. So let me make it bigger here. So for month 2, the return is negative 0.1. The previous month was 2.1. So basically, what you do is you do right click here, copy that, you put them here, and put them in the values. And now you got the RT and the RT minus 1. Okay, so that's what you have here. You can do delete here now and copy those, put them here for now. I'll explain for you later. Now, we're going to go back to the handout. As I said, back and forth, back and forth. I'm very patient to do it, to show you how to do it. So we need to estimate, we need to go 2 steps. First step is to estimate this model. All right. So what's the ultimate goal? Again, the ultimate goal is to calculate the parameters. The ultimate goal is to calculate the parameters R down, R up, alpha, and beta. So I need to know what's going to be, if it's a good, if Apple going up, what's the return is going to be up? If Apple going down, what's the return going down? And then what's the chance to go up and what's the chance to go down? All right. So I need to calculate these quantities. So I need to estimate this model. I'm going back to Excel. And I say, amigos, I need to estimate RT over RT minus 1. So the way to do it is simple. Is there's something called data analysis, but maybe you didn't have it. So let me take it off. So uncheck this, uncheck this. See, this is gonna go now. When I do okay, this one is gonna go, so go. All right, so that's gone. All right, so now we need data analysis. How to get it? You go option, file, options, add ins, go, and you click these 2 balls, and there's a Bloomberg here, Excel tools if you want it. You do okay, and then this one is gonna come, data analysis. You choose, there's a lot of, in this class we're gonna use other things. We're gonna do a solver also. But for now, we need the regression. This is a regression. You do okay. And now it's the what's a Y input? Well, let's go back to the handout. What's the y is RT, what's the x is RT minus 1. So our y, I'm going to include the first row. And what's our x? Then did you put the labels? Yes, we put the labels. That's the reason I put them here. So labels, check this box. You want the constant to be 0? No, we didn't want the constant to be 0. We need to estimate the a here. We need that constant. All right. Do you want that a new workshop? Yes, we said, okay, fine. So here we go. This is the outcome of the regression. So what we need from here, we need 3 things: the intercept, the row, and this one. These are the 3 things that we need to take from this regression. But before we go that, we need to talk a little bit about regression. So the R square reflects, what is that R reflects? That's the most important, one of the most important component statistics. Reflects the fitness of the model for which, comma, when it perfectly fit means R square equal 1 and perfectly unfit means R square equals 0. So it reflects the fitness of the model, and it is between 1 and 0, for which perfectly fit means R square equal 1, and it's not perfectly R square equals 0. So now we are 0.07. Is that good or not? It's good, actually. For this retain models, we estimate the retains. This is very good. Okay, it's R square, not very good, not very bad. We're going to live with that. So now I'm going to put the intercept here. Go back to the Word document. We need the A and the row, and we need the standard error. We need this standard deviation for the standard error. So I'm going to put that in yellow. I'm going to put that in red. And I'm going to put that in green. Perfect. Go back to Excel. So I said this is in yellow. This is in red. You can ask me, Joseph, why you do the colors. You understand. Don't worry. Not this one. Undo. Red. And the green. Okay. So now, this is, we're going to call it regression output. So now we're going to go to the leapfrog model. And now we're going to have the red row, the zigzag, and the yellow. See the colors here? So you have to put the inputs. So the input for that equal the row. You go here. That's our row. Red with red. Enter. Now this is a green. Zigzag, well, there's going to be equal to the green. You go to the regression output. You go here. Enter. And then we need the constant. It's equal to constant. Enter. Now we're done. We are done. We are done here. And what we have is, for next month, the return can be negative 0.0019 or 0.0019. If we are in a low state, the chance to be in a low again, like if you are in negative, it's 4.5 to stay twice in the month, back-to-back month low. But there is 95.5% chance that this is going to be high. And then if you're on a high, to go to low, there's a chance of 5.9%. But if you're on a high, there is a high chance to go to high again, 94.1%. So now the question is, what is our current state? Well, our current state is 0.068. So 0.068 is above the average. Okay, so the current state is 0.06-ish, which is higher than average. Therefore, we are in the higher state. Done. We're done. Perfect. We go to the leapfrog. Now I'm in the high state. So there is a chance for Apple next month, 5.9% chance to go from high to low, but there is a 94.1% to go too high for Apple next month. So the expected return for Apple is the following. Well, it's simple. Is this number equal this number multiplied by this number? No, we are in a high, right? We are in a high. We are in a high, so I'm going to use this row. This number multiplied by this number plus the complement multiply by this number. Done deal. This is the expected return for Apple. The price for Apple is 133. Current price is 133. Projected price equal this multiply by 1 plus this, amigo. Enter. Life is beautiful. So we expect to be 133 too. So that means we're going to be flat. We expect next month to be very flat here. Okay, so this is the leapfrog model, and this is the Monte Carlo. I did before the class. I did some things so to prepare myself for my presentation. I'm gonna delete that. So you're gonna see this Monte Carlo, this regression output. I just talked about it. Now use it. You're gonna see leapfrog, and you're gonna see the data here. Okay. Oh, something happened here. Oh, I took the wrong one. No problem, because they are the same results. So I'm gonna go here, row equal this one, Zach equal this, SC equal this one, and the constant equal this one, and we're back where we've been before. Excellent, very good. Good. So the final question, and we'll stop the video so you can replicate the work, is which model to use? Which model to use in this case? By the way, when you go to the Markov chain handout, you can see this, the colors and everything. There is state duration, which is 1 divided 1 minus alpha, and the duration for that is 1 divided 1 by beta. So how much alpha was? Alpha was low to low and high to high. So you can calculate the duration also. Shouldn't I calculate the duration here? Yep, here is duration. It's calculated for you. So for low state is 1 month. For high state, it could be 17 months. So you have the duration also. So which model to use? Well, if you go to the output, the row here is negative. It's negative 0.2, which is mean not zero. Let's go back again. That the leapfrog says, handout, that this model right if row is not equal 0. If row equals 0, that means we are random walk. But to be honest with you, this model is not, it's not great because the results are not, row is not 0, that's right. But if you look here to the output of the regression, the t-stat is very small, below 2 absolute value, negative 0.8 or 0.8 absolute value, below 2. So that's not very significant. So we're still in between the Monte Carlo and the leapfrog. If you put a gun, I would choose a leapfrog. model. So now you have a leapfrog, Monte Carlo, regression output, the data. What's your homework? Your homework is to pick a company, do the return, get the moments, put them in a simulation moment, do some analysis here, do the regression, take the data, put them in a leapfrog model, do the regression, show me the output for the regression, put them in a leapfrog model, and you're done. So it's a video. You have to do a video. It's going to be a little bit more time than usual, but it's a lot of analysis here. Again, this is a PhD level quality. Behavioral finance is a technical analysis with some mathematical and physics models approaches we use here. It's beautiful models, enrich your understanding because you're talking about price projection. Monte Carlo, you can use it for other things in health and in war. If you have an enemy, you want to see the number of rockets you're going to go tomorrow. What's the chance you're going to have 60 rockets or more? You can do that here. All right. So, and then the leapfrog, you can use it for other things. You can revenue projection, income projection, dividend projection, cash flow projection, a lot of beautiful things. So create this video and post it. Thank you very much and bye.